Hello everyone, hope you all are doing great. Guys, today in this video, I am going to make you understand how to configure EtherChannel load balancing algorithm. As you know, by default, the EtherChannel load balancing algorithm which is running on Cisco switches is source MAC address, but there is some problem we had discussed in previous class, in previous video. Okay, so today in this video, we are going to discuss advanced things, the things which nowadays industries are using, right? Organizations are using, right? So as a network engineer, if you are working, definitely you should watch this video till the end. And this type of video is not available on YouTube or on Google. Suppose if you will search the command to change load balancing algorithm in EtherChannel, you have to spend lots of time on internet. Then maybe hardly you will get command. That means these advanced things is still not available on internet, and I am providing you this video at free of cost. So please make sure you will watch this video till the end. Definitely you are going to learn something that in real time organizations are using. And if you are an engineer, you can also help to your organization to grow, right? Because if you will configure network like if customer is able to access internet or able to communicate with their remote branch smoothly, that means organization is getting benefit. Definitely organization will get benefit, yes or no? Because everything depends on network. So if you are a network engineer, make sure you will suggest to your organization that we should change the load balancing algorithm or these things. Easily, definitely you will not get this type of information, but in this video you will learn lots of things, lots of verification command here I am going to run. Right, we are going to perform load balancing between switch 1 and switch 2. Okay, so without wasting our time, now let's start. First of all, I must tell you that this configuration is not possible on the simulation software like EVNG, GNS3 and packet tracer. So I am going to create this topology on my rack. Okay, this thing you cannot configure. The command which I am going to use in this video, I am going to configure run on the switches. Those commands will not work on the switches on packet tracer, GNS3 and EVNG. Okay guys, so make sure whatever command I will use, you can note down that command in your notebook somewhere, right? Definitely that will help you to work in the industry. Okay, if you will suggest to your organization will definitely appreciate you. Okay, now see, suppose this is ISP. This ISP is connected with one router R1, and here I have switch 1 and switch 2. Switch 1 is connected with two PC, PC1 and PC2. Here I am running IP 10.1, here I am running IP 10.2. The default gateway will be what? 10.1.1.100, 10.1.1.100 for both PC. This is the default gateway, yes or no? So suppose if this user wants to access internet, this PC will send traffic to switch 1 will forward to switch 2, and switch 2 will forward to router will forward to ISP. When ISP will generate reply, it will send to router 1, router will send to switch 2, and again switch 2 will send to switch 1, and then switch 1 will send to PC 1. Yes or no? This is how these user will access internet. Now between switches we need more bandwidth, right? Because suppose there are 10,000 user, okay, behind switch 1, so we need more bandwidth between switch 1 and switch 2. So that's why I am using 4 link between switch 1 and switch 2. Port number 0/19 to port number 0/20. Here I have bundled these all linked together with the help of LACP protocol. And by default, load balancing algorithm which is running over here on both switches is source MAC address. That means to perform load balancing, switches will check only source MAC address, yes or no? So there is some problem. If switches will use source MAC address to perform load balancing, switch will perform load balancing for the traffic which this machine will generate for the outside. But when this router will send traffic to switch, it will use a single link, because every time source MAC will be what? MAC address of this interface. Let me show you what I am trying to say. Suppose MAC address of this machine is A, MAC address of this machine is B, and MAC address of my default gateway is suppose C. So if this machine wants to access 8.8.8.8, so source IP will be this one, destination IP will be 8.8.8, source MAC will be A, and destination MAC will be what? MAC address of default gateway. Source MAC A, destination MAC C. So when switch 1 will receive this frame, switch 1 will perform load balancing. For that it will check source MAC address. So source MAC address is A. Maybe it will use this link, this link, this link, this link. Any one link switch 1 will use to forward traffic of PC1 to switch 2, and then switch 2 will forward to router 2. Okay, when this machine will generate a request for the internet, maybe it will use another link. Suppose for PC1, switch 1 have used this link, right? And for PC2 it has used this link, right? Because PC1 source MAC address is A, PC2 MAC address is B. Okay, so here source MAC will be B and destination MAC will be C. Okay, so suppose switch 1 is using this link for PC2 and this link for PC1, but whenever this machine will generate reply, it will generate reply for suppose PC1, then also source MAC will be what? C, destination MAC will be what? A. If this router is sending traffic to PC2, then also source MAC will be what? C, destination will be what? B. So source MAC will be same whenever router will forward traffic to switch. So definitely this switch will use a single link because it is using only source MAC address to perform load balancing. So today in this video we are going to change the algorithm. We are going to set which algorithm? We are going to say you need to use source and destination both MAC address to perform load balancing. This is really advanced things. Okay, so make sure guys you will watch this video till the end. If you have not subscribed this channel, please subscribe this channel before starting this video. Fine. Now I am going to show you that I have access of all these devices in the secure CRT. Here you can see I have access of switch 1. First of all, I am going to down all interfaces of this switch. So interface range F0/1 to 24 and say shutdown. Okay, by default all ports of switch is up, so I have down the interface. Here also I am going to run shutdown command on all interfaces. Interface range F0/1 to 24 say shutdown. Now I will run no shut command only on those interfaces which I am using here. Okay, so on router 1, I think I have already configured IP address on router 1 on PC1. So IP interface brief. Yes, here I am running what IP? 10.1. This protocol is down. Okay, so switch interface is down. That's why it's showing you down. Don't worry. Here on PC2, let me check IP address. So IP interface brief. Here I am running what? 10.2. And on the edge router, this is my edge router. Here I am running what IP address? So IP interface brief. Here I am running IP 10.100. Okay. Now, see, this interface is 0/19. This is 20, 21, 22. This is my 0/1. This is my 0/2, and this is my 0/3 because this is router 3. Okay, so I am going to run no shut command on these interfaces of switch. Okay, so let me take you on switch number 1 first. Here, exit interface range F0/1 to 2 says no shutdown. Okay, after that interface range F0/19 to 22 say no shutdown. Okay, let me do same thing on switch number 2 also. Interface range F0/3 and after that F0/19 to 22 say shutdown. Okay, now if you will check show IP interface, now you can see line protocol is up. Yes, of PC1. Okay guys, now I am going to bundle these all link together of between switches. Okay, but before that, if you will check connectivity, that connectivity is there or not. So ping 10.1.1.2. Let me ping PC2 from PC number 1. Let me check. Yes, it's working. Let me check that am I able to ping my gateway 10.1.1.100. Yes, I am able to ping my gateway. Okay, from PC number 2 also you can verify ping 1.10.1.1.100. Yes, I am able to ping. Yes, now I am going to bundle interface F0/19 to 21. So interface range F0/19 to 22. Say channel group, what group number? Let me use 1. After that mode is we can configure active here, right? Let me do same thing on switch 2. Interface range F0/19 to 22 and channel group number is 1 and mode is, let me configure passive over here. Okay, so if you will run command like so EtherChannel protocol, you can see I am running which protocols? LACP, right? On switch number 1 also you can verify it. So EtherChannel protocol. Okay, LACP. So Let me check that my port channel is up or not. So IP interface brief, or by running this command, or you can use what? So interface P1, port 1. You can see down here. Yeah, now port is getting up. So this, I think now it will come in up. Yes, now you can see protocol is up and the status is also up. On switch number 2 also you can verify. So interface P1, are you able to see? Protocol is up, status is also up, right? That means ether channel is working fine between switch 1 and switch 2, right? Now guys, here on PC1 I am going to change the MAC address, right? Let me change the MAC address, and if you want to check MAC address, so interface F0/0, here you can see MAC address of PC1 is 000000000A. I have already changed the MAC address. Yes, over here as well on PC number 2. So interface F0/0. Here I have configured what? D. So let me change here. I am going to configure what? B. Interface F0/0 and MAC address 000.000.000B. Fine. Let me check what is the MAC address of edge router interface, my default gateway. Interface F0/0. Here MAC address is okay. Line protocol of this interface is down. Line protocol of this interface is down. So I think on switch. So interface status 0/3. It is connected, and so IP interface brief. Here 0/3 is up. So why line protocol of this interface is down? So IP interface brief 0/0. Okay, I am using 0/1 over here. No? Yes, okay, this is 0/1. 0/1 interface of router 1 is connected with switch 2. Okay, so interface F0/1. Here you can see the MAC address is what? This one. I am going to change the MAC address over here as well. Config T, interface F0/1, and say MAC address 000.123.4, and let's say E. So here I have configured this MAC address. Fine. Now guys, tell me, this switch, if PC1 will ping suppose 100.1.1 10.1.1.100, this switch will use which link? Source MAC will be what? A. Destination MAC will be what? E. By default, the algorithm which is running for load balancing is what? Source MAC. How you can verify it? You can verify it by running one simple command. You know what command you will run here to check the load balancing algorithm? So ether channel load balance. Are you able to see the default algorithm which is running on switch is source MAC, right? On switch number 2 also, if you will run command, so ether channel load balance, are you able to see the default algorithm is source MAC, right? That means switch will use only source MAC address, right? So it will translate what? A into binary. Binary of A will be what? 1010. There are only 4 links, so switches will use last 2 bits. Yes or no? 1 and 0. What will be the decimal value? 2. It will use which link? Link number 3. Yes or no? How we can verify it that switch will use which link? Okay, let me show you. Now switch is performing load balancing, right? How we can check? Test ether channel. After that interface, let me put question mark over here. Yes, load balance. Test ether channel load balance. After that interface port channel 1, and then you can define the IP or MAC. So now I am using layer 2 ether channel, so I am defining MAC over here. After that you can define source MAC. So source MAC is what? 000.000.00A. So what I am asking to this switch, that when source is this one and destination is 000.000.000E. When source is this and destination is this, you are using which link, you are using which port, right? By running this command, switch will tell you that switch is going to use which link for this source and this destination. See, it is going to use what? Port number 22. Okay, it is going to use port number 22. If you will check for PC number 2, whose MAC address is what? Whose MAC address is 0B. Let me ask to switch. See, switch is saying would select 0/21. That means when PC1 will ping, it will use this port 0/20. When PC2 will ping, it will use link number 21. That means definitely switch is performing what? Load balancing, but only for the traffic which is going from here to here. But all the traffic which is coming from here to here, this switch will use only single link. Let me show you that also. Let me take you on switch number 2, and on switch number 2, okay, I was running this command on switch number 2. Let me run this command on switch number 1 as well. Test EtherChannel. After that, EtherChannel, and then load balance, interface, port channel 1, MAC, and source is what? 000.000.000A, and destination is 000.000.000E. Right? Switch is going to use which link? 22. For PC number 2, B, it is going to use which link? 21. Right? Now I am going to show you on switch number 2 what link this switch will use for the traffic which will come from router 1. Every time source MAC will be what? The MAC address of default gateway, E. Yes or no? So not so. Test EtherChannel, load balance, interface, port channel 1, MAC address 000.000.000E, because source will be this one every time. Destination is 000.000.000A. It is going to use which link? Port number 19. For the machine B, for the computer B, it is going to use what? 19 link. For both, it is going to use what? 19 number link. For any other user, suppose I have a user whose MAC address is C, 19 number. Suppose I have a user whose MAC address is 1.1.11. See, it will use only a single link. Switch 2 will use only a single link to forward the reply. Whenever these user will send traffic, definitely this switch will perform load balancing, but this switch will not perform load balancing for the reply packet. Yes or no? It will use only this link 0/19. So guys, here we need to change the load balancing algorithm. Yes or no? On real time also, if you are working in an organization, please check that if their engineer have configured the EtherChannel, they are performing load balancing or not. Maybe you have connected multiple link between switches. I am damn sure if 10 people will check in their organization that there are multiple, definitely there will be multiple link between switches. Maybe they are not using EtherChannel, right? So if you are not using EtherChannel, first of all you should use EtherChannel, right? Because HTTP will allow you to use only single link, but with the help of EtherChannel you can utilize all link. And if you are using EtherChannel, you have configured EtherChannel, then what you need to do? Then you need to change the algorithm so that switch will perform load balancing for all traffic, for incoming traffic as well as for outgoing traffic. Okay. So now see how we can change the algorithm, that load balancing algorithm. So on switch number 1, first of all, I am going to change it. I'm going to tell to switch that you should use both source MAC as well as destination MAC to perform load balancing. Okay, how we can do? We can say here port channel, after that load balance, and if you will put question mark over here, you can see the 6th algorithm. You can use any algorithm from here, right, to perform load balancing. So I am going to use destination and source and destination MAC. Source, destination MAC, this one. By default, this one is running. Okay, so let's say source, destination MAC, right? After running this command, if you will check, so EtherChannel load balance. Now you are able to see the algorithm which is running on switch is source destination MAC. Guys, by default source MAC algorithm is running, right? So in real time you need to change it. Okay, if you will not change it, then switches will perform load balancing only for the traffic which will go from inside to outside. The traffic which will come from outside to inside, for that switches will not perform load balancing. Okay, so now here also I am going to change the algorithm. Say port channel, after that load balance, and source destination MAC. Okay, got it? Now on switch number 2, I am asking to switch to that. Tell me now which link you are going to use for this source and this destination. Okay, so it's saying that I am going to use which port? 21 number port. Let me ask, suppose source is this one and destination is PC1 000A. So it is saying that I am going to use port number 29. Which port you are going to use for PC2? I am going to use port number 20. Yes or no? Now it is using both source MAC as well as destination MAC. So that's why it is using multiple link na? Yes or no? Yes. It is. Now it will use this link for PC2. It will use this link 0/19 for PC1. We had already discussed that how switches will perform load balancing, right? In the previous video. So if you have not watched that video, first of all you should watch that video. Okay guys, now how we can verify? Let me send some traffic from PC1. Okay, so MAC address of PC1 is what? A. MAC address of router is E. So source is A, destination is E. So let me ask to switch one that you are going to use which port? Okay, for the source MAC will be A. For the A. It is saying that I will use which port? F0/19. So I am going to check. So interface F0/19 output traffic. That if I will ping, definitely output count will increase, right? Packet out will increase here. So include packets out. Got it? Now you can see how many packets have out from this interface. How many packet has out from this interface? Approx 2700. Now I am going to send 10,000 packet from router, from PC1 to router. Ping 10.1.1.100. Repeat and set 10,000. What happened? Ping is not working. Can I ping from PC2? Ping 10.1.1.100. No, yes, I am able to ping from PC number 1. Why it's not pinging? Am I able to ping PC1 from here or not? Let me check. Yes, I am able to ping PC1. So PC1 is not able to ping router. Why? Let me check here on switch number 1. So interface status 0/1 is connected. Here I have connected router 1. So yes, it's fine. Router 1 should ping 10.1.1.100. So everything is fine. Let me check that from here I am able to ping router 1 or not. Ping 10.1.1.1. Yes, I am able to ping 10.1, but why it's not sending? Yes, now it's working. Yes or no? Okay, earlier it was taking time. I am configuring on real devices. So maybe if you will send 10,000 traffic, CPU utilization of device can be high. Due to that, devices was dropping the traffic. But what I am saying, I have here sent 10,000 packet from PC1 to router. So output packet count will increase on which port? On 0/19 port. Here you can see. Now output traffic is around 12,000. Yes or no? But on 0/20, on no any interface, output count will increase. Yes or no? Here you can see. Okay. Now I am asking to this switch that which port you will use for the PC2. For the PC2, whose MAC address is what? B. for the B MAC address, it is saying I am going to use port number 20. Okay, so now on port number 20, if you will check, see the output traffic is this one, yes or no? And on 0/19, this one, right? So if PC1 will send packet, output traffic, output count will increase over here on 0/19, and when PC2 will send traffic, output count will increase over here on 0/20. Yes, now I am sending 10,000 packet from PC number 2. First of all, before that, let me send 10,000 more packet from PC1. Say 10,000. Okay, now on switch number 1, you can see, okay, output packet is increasing, yes or no? But on 0/20, it's not increasing, right? Now I am going to send 10,000 packet from PC number 2. Ping 10.1.1.100 and repeat 10,000. Go to switch number 1. Here you can see port number 19, port number 20. So here output packet is increasing. Output count is increasing, yes or no? So that means for PC1, this switch is using which link? Link number 1. For PC2, this switch is using which link? This link. If I will change the MAC address of PC1, what will happen? Let me change the MAC address of PC1. Config T interface F 0/0. Say MAC address. I am going to say 000 or say 111. Okay. Now I am going to ask to the switch that which link switch is going to use. So, not so. It will be test, EtherChannel, load balance. After that, interface, port, channel 1 and MAC. Source is 000 not 111. No. Right. Destination is 000 E. See, this switch will use which link? Link number 19. Okay. So now on switch number 2, if you will check, what? That switch is using which link? If PC1 is pinging, or PC2 is pinging to router 1, which link switch 2 will use? Here also you can check by test, EtherChannel, after that load balance, then interface, port channel 1, MAC address and 0.0.0.00000E, and destination is 000.000.000B. It is saying that I am going to use with this link, right? So let me check the output count on this interface. So interface F 0/20. After that, section include packets output. Okay. Now here you can see around 10,000 packet has out from this interface, right? Now I am going to send 10,000 packet from here to router. So now switch number 2, see, output packet is increasing over here, yes or no? That means it is using this link. But if I will send 10,000 packet from PC number 1, switch number 2, see, here is output increasing here? Yes. That means for PC number 1 also it is using same link. So let me check what is the MAC address of PC1. MAC address of PC1 is what? 111. Okay. So let me copy this MAC address from here and go to switch. Say test, EtherChannel, load balance, interface, port channel 1, MAC, sources what? 000.000.000E. Destination is this one. I have copied it, so let me paste it over here. It is saying I am using which port? Port number 20. So see, on 20 port number, output count is increasing, yes or no, guys? So this is how we can change load balancing algorithm on switches. Okay, and if you want to change again, if you want to use another load balancing algorithm, we can do that. Now you have command to change the algorithm, but you know, if you will search this video on YouTube, let me open YouTube over here, you will not get a single video like say EtherChannel load balancing algorithm, or you can run command to change. See, these are the video, but in a single video, no one have explained how to change load balancing algorithm. They all are teaching just simple thing. What is EtherChannel, how load balancing will perform, okay? But I have explained everything here, guys. So please, now last request is, if you have learned something from this video, please hit on like button. If you have not subscribed my channel, please subscribe this channel. Okay, if you want this type of video, whenever I will upload, you want notification, you can click on bell icon as well. That's all for today. Bye bye. In next video we will understand the maybe another things about the EtherChannel. Okay, otherwise I think I have covered everything in EtherChannel. Okay, and one more thing here I am showing you. If you want to change, if you are suppose you can using what layer 3 EtherChannel, and then if you want to perform load balancing, you can change, you can configure which algorithm, source IP, destination IP. Here also we can use source IP, destination IP. Yes or no? How? Port channel. After that, load balance. After that, here are you able to see the algorithm, right? What I am saying, I want to use source IP. See, after that, clear. So if I will run this command, this switch will start using what? Source IP to perform load balancing. Then it will convert into binary to IP address, right? So any algorithm you can use from here. We have 6 type of algorithm to perform load balancing, but by default source MAC is running, but source MAC cannot perform load balancing for the traffic which is coming from outside to inside. It will perform load balancing for the traffic which is going from inside to outside only. That's all for today, guys. Thanks for watching. Bye bye.